So we're going to discuss derivative rules, which means we're finally going to finish up the chart of derivative rules. So we've done most of this, but we got to get the trig rules down, right? These trig rules we haven't put in use yet. So the trig rules, all the trig rules use the chain rule. So just like the rules we've gone over recently, like the e to the x rule and the ln x rule, if x is a function and not just x, then you have to take the derivative of the function. So we'll cover what these are. Make sure you fill them out. You don't have to memorize this for this course, although in most calculus courses you would. So if f of x is sine of x, then f prime of x is going to equal cosine x. Okay, so if the function were sine x, let's say it was sine of, let's say 3x squared plus 5x, then when we take the derivative, we would have cosine of 3x squared plus 5x, cosine of 3x squared plus 5x, all right, times the derivative of what's inside. So times 6x plus 5. Okay, so we have to follow the chain rule. Cosine x. Cosine x, the derivative of cosine x in general is equal to negative sine x. So notice sine x is cosine x is negative sine x. So when we go from cosine to sine, we have to take a negative. So let's say we had cosine of, I don't know, cosine of, I don't know, 3x to the 5th. Okay, so we would have negative. I'm actually going to leave space for the derivative of this. Instead of putting it after, I'm going to put it before. So negative cosine of 3x to the 5th. I did that wrong. That needs to be sine, not cosine. Let's change that right now. We have a negative. We're going from cosine. Go from cosine, we go to sine. So negative sine. And then here we need the derivative of 3x to the 5th. So that's going to be 15x to the 4th times sine 3x to the 5th. Right, so that's how you do those two. Now, these get a little more complicated to memorize, but they work the same way. So tan x is the derivative of tan x becomes secant squared x. Now, we haven't really worked with secant squared that much, to be honest, but this means that we're squaring secant x. It's really secant x times secant x. Another way to write this would be to put the whole thing in parentheses, not just the x, but the whole thing in parentheses, put a square on it. But this is the normal way to write secant x times secant x, secant squared x. All right. So same chain rule applies here. If we have tan of, I don't know, 3x, then we're going to wind up with the derivative of 3x is 3, so I'm going to write that first. 3 secant squared of 3x. Okay. Cosecant. F prime of x, if f of x is cosecant, f prime of x is negative cosecant x times cotangent x. All right, so let's take cosecant of, let's do e to the x. E to the x. Okay, cosecant of e to the x, if we have that as our function. I'm trying to avoid the seam in my table. See this seam? Making it hard to write on. Cosecant of x, of e to the x. So we're going to start off with negative cosecant of e to the x this would be a really weird function, by the way, but there's no reason you can't do it, times cotangent of e to the x. Notice that the e to the x winds up in both of these places, right? But then we do the chain rule once. So we need to multiply this times the derivative of e to the x, which is e to the x. Normally we would write that at the beginning. In fact, I'm going to squeeze it in there. Let's squeeze it in the beginning. Equals negative e to the x times that stuff. There you go. So that's how we squeeze the chain rule in there. All right, secant. The derivative of secant. So secant x becomes secant x times tangent x. Works the same way as this. Let's say we have secant. Let's say our function is secant. Secant of 4x squared. All right, so we're going to have the derivative of 4x. I'm going to write that first, or 4x squared. I'm going to write that first. That's going to be 8x. And then we're going to multiply it by the actual derivative of secant, which is secant. X is this 4x squared times tangent of 4x squared. All right. And then cotangent. Cotangent is the last one we're going to do. And then we'll do some examples from the actual chapter. Negative cotangent becomes negative cosecant squared x. The thing to remember about all of this stuff, actually all of this stuff, all of it, I don't have the top filled out here, but all of it comes from the difference quotient, the instantaneous rate of change that we were doing, where this function is actually cotangent of x plus h minus cotangent of x, all divided by h, as the limit of h goes to 0. If you do the math on those, you come out with these rules, all right? Now, doing the math on these tangent rules aren't easy, and actually, you don't know enough trigonometry right now to do those. In some classes, we would have done that trigonometry first, but we didn't do that in this class. So here, same example as like above. So if we have cotangent x, the derivative of that, I shouldn't put equals. The derivative of that would be negative cotangent. Here, let's not use cotangent x. Let's use something more interesting. Cotangent of pi. Actually, you know what I haven't shown is theta. Let's use theta. Cotangent. So theta is an angle, right? And it's the variable, right? So it would be like x. But let's say we have cotangent of 2 pi theta plus just 2 pi theta. So from that, we would go negative. We have a negative from this. We have to take the derivative of 2 pi theta, which, since we're taking the derivative in terms of theta, not in terms of x, the derivative is 2 pi. 2 pi. Cotangent. Nope, that's not right. That's not right. The derivative of cotangent is not cotangent. The derivative of cotangent is cosecant. Cosecant squared. And then our x is our function. So that gets 2 pi theta. Okay. All right, so we'll do some examples after this. Both Mr. Parr and I will. Good luck with this. And we'll also take questions in class.